This is Professor Pelton. This is Trigonometry, Chapter 2, Section 1, Part 2 of 3. Now we're going to cover period and amplitudes of the sine and cosine graphs. The period typically was 2 pi for general sine or cosine, but now we're going to see they could be more or less than 2 pi. And we found before the amplitude of the sine and cosine was 1. But now that could be greater or less than based on the new maximum and minimum values. What's important here is the new formulas. The period can be modified, and the formula is 2 pi over b. And the amplitude can be modified, and the formula is the absolute value of a. And these come from the standard sine and cosine formula of a times sine of bx and a times cosine of bx, where a is some real number that will affect the amplitude, and b is some real number that will affect the period. Okay, and similarly for sine and cosine. Alright, so our new maximum values will no longer be 1 and -1 typically, unless it's a standard sine or cosine, and the period will not be 2 pi unless it's a standard sine or cosine. So let's look at some examples. Alright, so the first example, try to get the graph in there. So first we'll do the basic sine as an example. The typical sine starts at 0 and ends at 0. Halfway between it's 0, halfway between it's 1, and -1. So that is your standard sine cycle. And you can remind yourself of this by doing the unit circle, where you have 1, 0, 0, 1, -1, 0, and 0, -1, where the sine is the second value in each coordinate. Okay, so at 0 degrees, it's 0 for the first coordinate, so on and so forth. Okay, so that gives me a period of 2 pi, because it repeats every 360 degrees or 2 pi, and my amplitude is 1. Okay, so from the top to the bottom, my min and max is 1. So let's try 2 times sine of x. Well, let's try any one of these values. We'll try a different color here. We'll go red. Well, if I was going to plug something in like pi over 2, so let's say that I did 2 times sine of pi over 2. Well, sine of pi over 2 is typically 1, so as a result, that new one would be 2. So that new point is now at 2. So what's happening is it doubles all these values. So 0 is still 0, 1 becomes 2, 0 is still 0, and -1 becomes -2. Let me move that point. I'm a little off on that one. And of course, 0 times 2 is still 0. So what happens is everything is just multiplied by a multiple of 2. And 0 stays the same because 0 times 2 is still 0. So my period is still 2 pi, but now my amplitude is 2. Because that first number gives me the amplitude. The first in case was 1, now it's 2. Now it should be 1/2. So if we do similarly, 1/2 times the sine of pi over 2. Well, sine of pi over 2 is 1, so I get an answer of 1/2. So as a result, when I do a different color here, green, I'll get 1/2 times 0 is 0, 1/2 times 1 is 1/2, 1/2 times 0 is 0, 1/2 times -1 is -1/2, and 1/2 times 0 is 0. So we'll get a new graph there, with the period still 2 pi, but now my amplitude is 1/2. Okay. Alright, pause the video and try the student problem on the next page. Okay, next page we're going to do cosine. So cosine starts at 1 and ends at 1. Halfway between it's at -1. Halfway between those it's at 0. And again, you can check your unit circle to verify. Okay, so unit circle, 1, 0, 0, 1, -1, 0, and 0, negative 1, where the first values are the cosine. Okay, so cosine has a period of 2 pi and an amplitude of 1 by default. So now we want to know what happens when we multiply it by 3. Well, if we do cosine of 0 degrees, or 0 radians, well, that's 1, so now I get a 3. Okay, so because it's 1, everything multiplied by 3 as a result. So this 1 becomes a 3. The 0 is still a 0, so let's make this a red. There we go. So this 1 now becomes a 3. This 0 stays a 0. This negative 1 becomes a negative 3. The 0 still becomes a 0, and the 1 becomes a positive 3. So we get a new cosine, where this is still 2 pi for one cycle, but my amplitude is now 3. Likewise here, we'll do it in green. 3 halves times the cosine of 0 degrees, or 0 radians, is 3 halves times 1, thus 3 halves. So the period's still 2 pi, but my amplitude is 3 halves. Okay? Well, if I look here, 1.5 is right there. That's still 0. 1.5, 0, and 1.5. That gives us our new cosine. Alright, let's try the next example problem. So we're seeing in this case, all of these, the A is affecting the amplitude. Let's see what happens if we change B now. So in these cases we're changing B. So again, sine is going to be 2 pi with an amplitude of 1. So go to sine, starts at 0, ends at 0, halfway between it's at 0, halfway between that it's 1, and negative 1. So there is the standard sine cycle of one period. A little bumpy there, we get the idea. So again, you can do yourself a unit circle. 1, 0, starts at 0. And we have 0, 1, negative 1, 0, and 0, negative 1. Okay, and the second value is sine. Okay, so let's see what happens when we multiply by 2 in the inside. Well, let's say that one cycle all the way around is 2 pi, right? You go all the way around from 0, you get to 2 pi. Okay, let's say we plugged in 2 pi, for example. So if I plugged in 2 pi, that would give me sine of 4 pi. Interesting. So sine of 4 pi is the same as 2 pi because they're at the same spot in the unit circle. So either way, the sine value is going to be 0. Okay. My amplitude's still going to be 1, so we can put that on there. So the question is, what happens to the period? Well, what's happening is it's accelerating it because I went around the unit circle, 2 pi, and I actually went 4 pi all the way around. So it's going twice as fast. So as a result, I don't need to go as far because if I plug in pi, I'll actually have gone 2 pi. Okay, so my period using the formula is 2 pi over b. That's the period formula. And in this case, it's 2 pi over b, and the b in this case is a 2. So my period is actually pi. So I do one cycle in pi. Because I'm going twice as fast, it doesn't take as long. So I go from here to here in one cycle. Halfway between is 0. Halfway between is 1. Halfway between is negative 1. So there's one quick cycle of sine of 2x. If I have sine of half of x, right, let's think about what happens when I plug in 2 pi there. So sine of 1/2 times 2 pi, well, that only gives me the sine of pi. Well, the sine of pi is 0, which is fine. That means I've only gone half as far in 2 pi. So this is going half as slow as a result, because I have to plug in 4 pi to actually get to 2 pi. It's not going as fast. The amplitude's still 1, so we'll use a green here. The amplitude is still 1. But again, using the formula, 2 pi over b to get my amplitude. Period. 2 pi over 1/2 is my b value. So if I times it by 2 over 2, cancel, cancel, I get 4 pi. So it takes 4 pi to make one cycle. So from here to here is one cycle. Halfway between is 2 pi. Halfway between is pi, and halfway between is 3 pi. There is my one cycle of sine of 1/2 x, because it takes twice as long since it's half of x. Alright, pause the video, try the student problem. Okay, so for the next one, our typical cosine, we'll do that in blue. We get period of 2 pi and amplitude of 1. So cosine starts at 1 and ends at 1. Halfway between it's at -1. And halfway between that, at the pi over 2, it's at 0. And the 3 pi over 2, it's at 0. So that's your typical cosine cycle. Okay, we'll try the next one here. Cosine of 3x. Let's see what happens there. So if I do that, 2 pi over b, so it's 2 pi over 3. So that means for this one, my amplitude is still 1 because it's a 1 in the beginning, but now my period is 2 pi over 3. So it's very short because it's going 3 times faster. So I go to 2 pi over 3, and I can put the end of my cycle. So I start here, and I end at 2 pi over 3. That's right there, so I end right there. So halfway in between I'm at -1. Halfway between that I'm at 0 and 0. And I get one quick cycle. And went 3 times faster with that one. Alright, next one, cosine. 2 pi, oops, let's go different color actually. So erase that. We'll go to a red. 2 pi over b. So it's 2 pi over 1/3 this time, because it's cosine 1/3 x. So we'll multiply by 3 over 3, cancel, cancel. So this one goes 6 pi, because it's a third slow. So it starts at 1 and ends at 1. Halfway between 0 and 6 pi is 3 pi, so that's at -1. Halfway between 0 and 3 pi is, let's see, that'd be 1.5 pi, so that's 3 halves. And then halfway between 3 and 6, that's, what's that, 4.5 pi, so that's 9 halves. So 9 halves. So there's our one cycle of cosine. That's at third the pace, so it took 3 times longer to get there. Okay? Alright, so long story short, when you have a function a times sine of b, x, or y equals a times cosine of bx, the a is going to affect the amplitude, and the b is going to affect the period. Alright, let's try 2 more. Okay, so first off, the typical sine, the period is 2 pi, the amplitude is 1. I'm not going to graph it this time though, because if you notice my axes, there's no pi's in my x-axis. It's going to be a little hard to graph. I could do it because it goes to 2 pi, which is about 6 point-ish, right? Because pi is about 3.14, so 2 pi is about 6.28. So I could estimate it, but I'm not going to. It would be a little rough to get it on there. It'd take up the whole graph. But I will do this here. The period's still going to be 1, because there's just 1 there. But the amplitude's 1. What am I saying? Get that backwards. And the period is still going to be 2 pi over b. But in this case, the b is pi. So I get 2. So my typical sine cycle starts at 0 and ends at 0, but my cycle is 2. Alright, halfway between it's 0, halfway between it's 1, and negative 1. So in this case, we actually have a whole number axes, okay, for the sine of pi x. Whereas if you did the typical sine, just estimating it, right, it has to go from 0 to approximately 2 pi. Halfway in between is pi, which is about 3.1 something, so that's like right there. And halfway between that, so it'd be something like this. Oops, I went too low there. So it'd be approximately like that. But again, we're trying to estimate the general sine because we don't know the exact values due to the fact that this is nice whole numbers here. Okay. All right. Pause the video. Try the cosine problem. Okay, same thing again. The period of cosine is 2 pi, and the amplitude is 1. Those aren't going to fit nicely on this graph because, again, this is not going in terms of pi. It's going in terms of nice rational numbers. So we'll just put the cosine 1 of pi over 2 on here. So the period's still going to be 2 pi. I'm sorry, amplitude is going to be 1. But the period is 2 pi over b. But in this case, I have 2 pi over 2. So the pi's will cancel, and I'll multiply by 2 over 2. That'll cancel, leaving me with a 4 for my period. So the cosine is going to go from 0 to 4. And of course, cosine starts at 1 and ends at 1. Halfway between, it'll be at negative 1. Halfway between that, it'll be at 0. And halfway between that, it'll be at 0. So there is one cycle of cosine if it's modified by a pi over 2 b value. And that is the end of part 2.